This is the beginning of step 4 of the Quiz 3 video lecture. Rhetorical question. Does all of our data line up? Does it all occupy the same relative space relative to state borders, cities, etc.? No, it does not. It is evident that our data does not line up. None of our layers use the desired NAD 1983 UTM zone 10N. The layers that have a spatial reference can be projected to the correct projected coordinate system, whereas one layer has no spatial reference. In this step, we will alter our data's spatial properties so that all of our data lines up and is in the same space. Imagine stacking all of the layers on top of each other, looking down from above. We will verify and fix this information now. Let's clear the projection of our data frame. It's already clear, but let's double check and zoom to the full extent of the data. Notice that the layers do not line up. Let's sort the layers: Tacoma proper SPH, City of Tacoma, tax shapes, miscellaneous shapes, Washington, and then the PhD data set will be on the bottom because it is a tabular data set. We'll clear it again just to be sure that we're not projected on the fly. And now let's zoom to each layer to make sure it's actually here. So there's Tacoma proper. Let's zoom to City of Tacoma. There it is. Tax shapes. Right there. Miscellaneous shapes. And then Washington. Now, all of the later layers are there. I'm going to save my map as step 4 since I've just reorganized my layers, and I'm going to turn on all the layers again. Save as, change the 3 to a 4, and click Save. Moving on to step 5. In this step, we will line up our data, ensure that all of our data is in the same geographic space. Our data will be in the same projected coordinate system when we complete this exercise. They will share the same geographic coordinate system. As discussed in the required readings, other video lectures, and online video, this week is all about coordinate systems and projections. Our data for all quizzes and labs from now on must be in the same projected coordinate system. By default, we're also ensuring that the data is also in the same geographic coordinate system. For all quizzes and labs, I will always tell you which coordinate system and projection to use. In this case, we'll be using a projected coordinate system because all paper maps should use a projected coordinate system. We will use Universal Transverse Mercator, UTM, projection named North American Datum, NAD 1983. Specifically, one designed for our area of the Earth in Washington, which is called 10N. NAD 1983 UTM Zone 10N. We will work through the layers one at a time. Due to the differences of the original coordinate systems of the layers, some of them require more fixing than others. Ultimately, all of our layers must end up in NAD 83 UTM Zone 10N. You must also use the test to determine what must be done to your vector layers in all labs and quizzes from now on. The question you should ask is, does the vector layer have any coordinate system or spatial information? So just for example, I'm going to open this one. The properties. This is what I mean by spatial reference. Is there something here? If yes, there is a spatial reference, we simply use the project tool to properly select the desired projected coordinate system for the quiz, lab, or project, etc. If no, we must first define the projection tool to change the native geographic coordinate system. If it is census data, which it most likely is in GIS courses at UW-Tacoma, the decision is easy. We define the projection to Geographic Coordinate Systems, North America, USA and Territories, NAD 1983. And if it is not census data, you must figure out the native geographic coordinate system, and that's beyond the scope of this GIS course. You then project the layer into the desired projected coordinate system, NAD 1983 UTM Zone 10N. For raster data layers, there are other rules, but for now we're just focused on vector data. We'll work with Tacoma proper SPH first. Refer to your previous answers or relook at the data and use the test to determine what must be done to get our data into the desired projected coordinate system. You must and will be asking yourself these questions with every single vector layer in your quizzes, labs, and projects throughout your career in GIS. When answering these questions, remember we are attempting to line up all of our data in the projected coordinate system NAD 1983 UTM Zone 10N. Written response 59. Does the vector layer Tacoma proper SPH have any spatial reference? Yes or no? Tacoma proper, we just looked at it. Properties, yes, it does. Does it have, if yes, it does have a spatial reference, what do we need to do? It is not in NAD 1983 UTM Zone 10N, therefore we should project. If it did or does not have a spatial reference, any spatial reference, we should have, the answer would be defined projection and then project. Question 62, therefore with Tacoma proper SPH, we should project. Using the project tool, as determined by the 4 previous steps and questions, I will now resolve the projected coordinate system. Tacoma proper SPH has a spatial reference, therefore I will simply project. I'm going to click cancel to get out of there. I'm going to pull up my toolbox by clicking the toolbox button. It takes a couple seconds to show up, and there's the toolbox. I'm going to rezoom to my miscellaneous shapes. In Arc Toolbox, I'm going to navigate to Data Management, Projections and Transformations. Move this over a little bit. And then Project, because that is the tool that we need to use. The input data set is Tacoma proper SPH. I should make sure that this button says hide help. If it says show help, you should always click it so that the help shows up. Notice that in gray, the input coordinate system of the layer pops in automatically. The output dataset or feature class will go to our data folder. And in this case, I'm going right to my data folder. And the name that I'm going to give it is Tacoma proper project 10N or PROJ 10N. Change it to TAC proper PROJ 10N, which to me means Tacoma proper projected into NAD 1983 10 North. I'll get rid of the SPH at the end and click Save. The output coordinate system, this is where we choose NAD 1983 UTM Zone 10N. I click on the little hand with the piece of paper, projected UTM NAD 1983 and then NAD 1983 UTM Zone 10N and click OK. A transformation is already added. If the transformation does not show up, sometimes you'll get a yellow box here. We would have to enter this by hand into this box and click plus. I'll show you if that happens. From here, I click OK. And very quickly, the layer is projected. And notice it has been added to the map. In this case, I'm going to remove the old one, zoom to the layer that was just added, and then clear my projection and see what happens to my map. I'll move this out of the way, click apply, and Washington disappears. Everything else disappears because this is the only layer at this point in NAD 1983 UTM Zone 10N. Click OK. If I go to full extent, you can barely see the different layers out in space. But for now, I'm going to zoom back into Tacoma proper. What is the current coordinate system of our data frame? Because it has been cleared, the answer is very easy. No coordinate system. So all of our data has gone to their actual spatial reference. Let's move on to tax shapes. Tax shapes had a coordinate system, so we project. We do not need to define. I choose tax shapes. There's the coordinate system. I change the name for tax shapes. I'm going to add the project PROJ 10N with an underscore. Save. The output coordinate system is the same one we chose previously. Projected coordinate systems UTM NAD 1983 Zone 10N. OK. And the geographic transformation has popped up again. I click OK. It runs. Here's the dialog box. You should be seeing these because there's a lot of data that we'll look into in later labs. For now, I'll close. And tax shapes, I'll remove the old tax shapes because I don't need it anymore. I'll zoom to tax shapes. And there it is. Going back, tax shapes, it does have a spatial reference, so we should just project. If it did not have a spatial reference, we would define and then project. Therefore, with tax shapes, as you just noticed, I just projected. I'm going to clear the projection of my data frame. And all but 2 layers should disappear. And now tax shapes is there and Tacoma proper, because those are the 2 that we've fixed so far. Moving on to the city of Tacoma. Does the layer have any coordinate system? Yes. If it does have a spatial reference, we should simply project. If it does not have a spatial reference, we should define and then project. Therefore, with the city of Tacoma, we should just project. And our name that we're going to name it is City of Tacoma Project 10N. Project City of Tacoma. Change the name. The output coordinate system is the same. And in this instance, I'm going to scroll to UTM, find NAD 1983, click on 10N, and then add this to my favorites because I seem to be using it quite a bit. And click OK. There is no transformation necessary. I'll click OK. It runs in 0.9 seconds. It was not added to the map. Thus, I must go to my data and find City of Tacoma, project 10N, and simply add it to my map. I will zoom to it to make sure I can see it, which I can. And now I'll clear the projection of my data frame. The three that I've fixed are staying. The other three, City of Tacoma, Miscellaneous Shapes, and Washington, are missing. And actually, City of Tacoma I have already fixed, so I can remove the bad one. And I still have 1, 2, 3, 4, 5 shape files. The next one is Miscellaneous Shapes. I'll turn these back on. And I have cleared the projection. I will just verify. I have not. So I should clear the projection, click Apply, and OK. Good. That's good. I double checked. Does Miscellaneous Shapes have any coordinate system or spatial reference? It does not. It's undefined. Therefore, given our rule, we must what? We must define the projection and then project. So if it does have a spatial reference, we would just project. If it does not have a spatial reference, we should define and then project. Therefore, number 75, with Miscellaneous Shapes, we should define the projection and then project. We define the projection by going to the Define Projection tool. And remember, this one does not create a new data set. We choose the input data set. The coordinate system is unknown, which is exactly what it is. It's unknown, and we are about to change it. We do not go to the original, or the NAD 1983 UTM Zone 10N. We must go to Geographic, North America, USA and Territories, NAD 1983, and click OK. So we're going to GCS, North American, 1983, and click OK. It was done in 0.02 seconds, but nothing has changed. It still looks the same. So we'll just close. Now, Miscellaneous Shapes has spatial information. It has a GCS. In effect, it's the same as Washington at this point. Now I go to Project. I choose Miscellaneous Shapes. It tells me what coordinate system it's in. I pick a file name, and in this case, I'm going to paste the file name, and then I'm going to add .shp to help get it into the map. Click Save. The coordinate system is now the projected coordinate system that we added to our favorites. No geographic transformation is required, and we click OK. I'll then zoom to Miscellaneous Shapes, and now it looks a little bit different because it's in a projected coordinate system, is not as wide. And Washington looks a lot less wide as well because it is also projected on the fly. Once I clear the coordinate system though of my data frame, Washington will go back to being wide. And in this case, it is. Miscellaneous shapes is still there, so I'm going to remove the old miscellaneous shapes. And I have just one data set to go. We'll work with Washington next. I have cleared the coordinate system of my data frame. Does Washington have any spatial information? Yes, it does. If it does have it, we should just project. If it does not, then we should define and then project. Therefore, with Washington, we should just project. In this case, we're going to create Washington project 10N. We do that the same way we just did the last step of miscellaneous shapes. We'll go to project, choose Washington, we'll give it a name, and I add .shp so that it gets automatically added to the map. The output coordinate system, I can use my favorite. Click OK and OK. Click close. Zoom to the most recently added layer. Remove the old Washington. And I can't see my layers. What is the selection below the table of contents that allows me to order my layers? And that's a question in the quiz number 80. Right now we're in list by source. Everything is listed from where it's coming from, data K3. But if I go to list by drawing order, I can sort my layers. So I'm now going to sort my layers with Washington on the bottom, miscellaneous shapes next, moving up, Tacoma shapes project, city of Tacoma, and then Tacoma proper on top. So we have Tacoma proper, city of Tacoma, tax shapes, miscellaneous shapes, and Washington project 10N. Clear the projection of my data frame, apply, and all of the data should now be in my viewing area. Tag proper, I can just barely see that turning on and off, but I'll go in reverse. Washington, I can see. Miscellaneous shapes, I can see. And now I'll zoom to tag shapes. There it is. City of Tacoma and tag proper. So again, tag proper, city of Tacoma, tag shapes, miscellaneous shapes, and Washington. And they're all in their own coordinate system, but the coordinate system matches. Going back to where our data resides, it should all be over here in data K3. The easiest way to determine that is to click on list by source. That is the selection below the table of contents that allows you to see the directory path. And here is the directory path. Data K3, user ID, quiz 3, quizzes, and my directory. If there were two paths, that would mean that some of my data was in the wrong folder, and I would have to fix it. If they were not coming from the data K3, the best way to fix it would be to right-click Data, Export Data, and then send it to your quiz 3. Send it to the proper place. In this case, I won't go all the way to do it because it's already in there, but I go all the way to my data K3 if it was in the wrong place. But it is in the right place because I've sent it all to the right spot, so I'm good. And that concludes step 5 of the Quiz 3 video lecture.